Hi. I gave you this question at the end of the last video. I believe you have done the work. So the answer is, to answer this question, uh, first, I would like to emphasize that you cannot use the the linear relationship because they are not linear, right? They are not linear because transformation from x to z is not simply adding something and multiplying something, right? So it's the increment is not uniform. When x changes from 0 to 1, z does not change at 700. But then x increases, then z increases by 1000. So it shows that the slopes are different at different intervals, so they cannot be a straight line. Therefore, our knowledge about the original random variables mean does not help calculate the new random variables mean. Then how can we do that? Just simply, you just need to recalculate the probability weighted outcome as we did uh, as we did earlier. So multiply 700 to 0.5, 700 to 0.4, 1700 to 0.1. So in that way, you get weighted outcomes and sum them. Then, as a result, we get $800. So $800 is the expected spending if I buy the discount ticket on eBay. So let's compare. Now the expected spending is $800, but earlier, without buying the ticket, if I pay the full regular price, then expected spending was $600, right? Just because I bought a discount ticket on eBay, and because of the potential loss of the ticket, because I may not use the ticket, buying the ticket on eBay is not worth. It's it rather increases the expected spending. So it's not rational to buy the discount ticket. Like, with facing this much uncertainty, have probability, half the times I would not use the ticket. That's the main problem, right? So it shows an example of nonlinear relationship, and also it shows how expectation can be used to make a decision. So when you think about what, if you need to take this discount ticket or not, then in an economic textbook, uh, this is what you have to do according to, if you are an agent, like as in an economics textbook, right? Microeconomics textbook. Anyhow, I will give you another interesting question, similar in under the same example. Now I find that Disney World have a promotion, like say annual membership. It has an annual membership program. So how it works is, it works like this. I pay $600 right now. I have to pay $600 as a as an annual membership fee, and then if I become a member, then I can get a discounted price for a ticket. So I can buy a ticket for $500. This is another deal I'm considering. So in this case, think about a new another random variable w, that is the spending if I join the annual membership program. So then that means I have to pay $600 right now. So even if I do not go to Disney World, I paid 600. But if I go once, then my spending is annual membership fee $600 plus ticket price $500. So 1100 is my total spending. If I go twice, then 600 membership fee plus 2 tickets, 500, 500. So the total will be $1,600. Probability do not change either here. In this case, calculate the expected total spending if I use the annual membership program. Try. Um, I try how you can do this. Pause the video. Now I will turn the page. If you have not finished it yet, stop the video now. I'll turn the page. The answer is 900. In this case, the relationship is linear because you can write W like this. So W equals $600 plus 500 times X. So plus $600 means this is spent regardless of the number of trips. So you have to pay $600 no matter how many times you go there. But for each trip, you pay additional $500. So one is on addition and the other is multiplication. So it's linear. And we know we are going to Disney World zero point 0.6 times next year. Therefore, plug in the place of X, I use 0 0.6. Plug 0 0.6 into the place of X, then 500 times 0 0.6 plus 600, which is 900. This is the expected spending. Also, if you compare this number to the other options considered earlier, it's even higher than the eBay discount. So it's not worth either. So anyhow, this is how calculating the mean helps making decisions. By the way, so just to see if this is really correct, so it's linear, and so we use the formula. But what happens if you take a more more fundamental approach like this? So outcomes in terms of W, if you use the annual membership program, and probabilities the same, then probability weighted outcomes are like these: 300, 440, 160. Summation is 900, which is the same as what we had in the previous slide. So uh, as I said, if they are the same because the relationship is linear. As long as the relationship is linear, you can you can calculate the mean more easily. That's what we learned in this example. I wanted to show you examples of nonlinear relationship and how to tell that. And right, okay, that's the end of an example. And I have another example. So think about state population data. I had to update it, but I haven't. Sorry about that. So it's the 2010 census. So like kind of outdated, but does not matter in our analysis. So think about population data by state. And population is measured in maybe millions. So California is absolutely the largest, has the largest population among all the states. So largest California, and Texas, New York, Florida. So there are states and other states, and there are two states who have population between 12 and 13 million. And say there are 8 states that have less than 1 million population. So in that way, this is a histogram. This is the histogram for state population distribution, right? Most states are located here, and there are some extremely large states like California, Texas, New York, Florida. So in this case, I'd like to calculate the mean. Let's calculate the mean. I do not uh, so so if you have the full data, I do have the real data, and then if you calculate the mean, you get 6.05. 6.05, about 6 million is the average population. On this histogram, 6, it's nearly 6, so 6 must be here, right? Right? So the mean is located here. And remember, the mean is a measure of center. So it says that if you say the mean equals 6.05, then you may interpret that as the center of this histogram, center of this distribution is 605, 6.05. However, the problem of this analysis is that there are there are 51 states. Maybe I think DC is included. So then if you count how many states are larger or smaller than the mean, there are 34 states smaller than the mean and 17 states larger than the mean. Then it's not a center. There are more states smaller than larger, right? So in this sense, and it is not an even split. It's not 50-50 split. So then how can we say it's the center? So it should be lower. So ideally the center must divide 50 states into 25 and 25. That would be another way to define a center. So yes, that is what we are going to consider. So the mean is an unbalanced center. It's not balanced. And so we are going to define another measure of center, which is called median. And the median is a measure that divides the sample exactly in half. So cut the sample half and half to the large side, to the large group and smaller group. So that's the median, definition of the median. So rough definition of median. And it will be denoted as median of random variable x or MED of x. So kind of obvious. In this data, in our data, Kentucky is the center because Kentucky is 26th largest state. So that makes 25 states smaller and the other 25 states larger than Kentucky. So Kentucky is exactly at the center that divides the sample perfectly half and half, and its population is 4.34. So we say the median state population is 4.34. So when you choose that point, that number, the sample is in a perfect balanced split. That's how we define the median. Okay, I'm going to continue with some exercises how to calculate the median from the real data in the next video. So thank you for watching and continue in the next one.